Today's topic is differentiation rules. And in the first part, we're going to spend 2 days on differentiation rules. Now, usually they give you a function with a function name, and the function looks like something with x's, and the x normally has an exponent and a coefficient. And instead of using the first principle formula, we can do differentiation quick and easily, short way. And today is the lesson about how do you do it the short way. The notation for differentiation, or the first derivative, is f accent x. And what you do is, you take this n to the front of the coefficient and you multiply it with a. So it will be n times a to get a new coefficient. And then it's x to the power of 1 less of that one. Okay, it will make more sense when we do some examples. But that is the notation for differentiation or to get first derivative. Now your form is important. What do I mean by that? It means that if you have the function there must be 3 things in each term of your function. If the function is about x, there must be an x. And that x must have an exponent. And in front of that x, you need to have a coefficient. So, our first example, fx equals 4x to the power of 3. The first thing that you do is you check for your form. Is it in the correct form and does it have all 3 boxes? We are working with x's, so do I have an x? Yes. Does this x have an exponent? Yes. And does it have a coefficient? Yes. Then, when we get the first derivative, we take this 3 to the front and multiply it with the 4. Okay, I'm gonna write the intermediate step. This step you don't have to write, but if it helps you, you can. So this 3 must be multiplied with 4. Then we have x to the power of 1 less from 3. This gives us 12x squared. And there we have our derivative. Easy. Let's look at the here.
Does it only have to be one coefficient attached to the x?
Yes.
So what if it was 4ax is the coefficient 4a?
Our next example, if x equals 7x. First, check the form. You have to have 3 boxes. I'm working with x, so I need my x. This x must have an exponent and a coefficient. What is the exponent? 1. Mooi. So the first derivative will be, take the 1 to the front. It's 1 times 7. X to the power of 1 minus 1. 1 times 7 is 7. X, 1 minus 1 is 0. You have to write the 0. Otherwise you're going to forget. Because this simplifies to 1. And then we have 7 as an answer. find the gradient. Okay, I didn't say find the gradient using the first principles, only find the gradient. So now you can use the short way to find the gradient. The first derivative equals, okay, first we need to get the form correct. I'm working with x's, there must be an x. But what will this x have as an exponent? 0. Mooi. And I need a coefficient. So now I take this exponent to the front, multiply it with 5, and you make the 0 one less. But 0 times anything is 0. The next one, px equals 4y. My function has an x, so I have to put in an x to the power of 0. Then 4y will be my coefficient. There's your question. Now I can get the first derivative, take the 0 to the front, multiply it with 4. 4 times 0 is 0. Okay, I don't have to work out the x because 0 times anything is 0. What if we have this? Py equals 4y. First make sure you have the 3 boxes. I'm working with y now, so y is the main peanut. It should have an exponent and a coefficient. The exponent is 1. The first derivative of p will be 1 times 4 is 4y to the power of 1 minus 1 is 0. And this part becomes 1, so the answer is 4. Any questions so far? Fx equals 2x to the power of 4 plus 5x minus 1. Now I have 3 terms. Each term must have the 3 boxes. X, I'm working with x. So I need an x with an exponent and a coefficient. I have an x, I must have an exponent, so it will be 1 with coefficient. I need to have an x with the power of 0 and the coefficient. And then I can get the first derivative. The 4 multiplied by the 2 gives me 8x. Make this exponent 1 less to the power of 3. Plus the 1 times the 5 is 5x. 1 minus 1 is 0. Minus 0 times 1 is 0. I don't even have to do the x. Now I get 8x to the power of 3. That is 1 times 5 is 5. Any questions? Example number 7. Gx equals x squared over 2. Now I need to write my 3 boxes. I'm working with x, so it will be x to the power of 2, but what will the coefficient be? Okay, sometimes I put in extra examples, so you just need to copy this one. That's why I said that you need to bring an exam pad for extra examples, and you can just put in the paper. So in front of the x, I have an invisible 1. And this, together with the 2 as a denominator, becomes my coefficient. That will be a half x squared. And now I have my 3 boxes. Now I can do the first derivative. G accent x equals. This 2 goes to the front and you multiply with a half. 2 times a half is 1. So x to the power of 2 minus 1 is 1. And that is x. Are you all with me for this one? Nice exam question, fractions. More possible forms. I think this is on your page. If we have x to the power of n over a, the x to the power of n can be separated from the 1 over a, and then you have your 3 boxes. Next one. A over b times x to the power of n. This x to the power of n must go to the top. So the exponent changes to a negative exponent. And what is left is your coefficient. This one. The x to the power of n must go to the top, so it changes to x to the power of minus n. And the a is in front of the x. Now there is a mistake on this one. That must be a minus. Just correct it. There must be a minus. It's number 4. First, we give this n, which is on the outside of the bracket, to every base. So the n goes to the b and the n goes to the x. But we want the x on top. So it becomes x to the power of minus n, and the rest is my coefficient. This one. The x can be written as x to the power of m over n to get rid of the root. And then we take this to the top, so it changes to a negative m over n, and a is in front of the x. Last one. Now I have 2 bases under the root, so a actually has a power of 1. 1 divided by n times x to the power of m divided by n. Okay. So these will appear in your homework and in exam questions and tasks, etc.
With number 6, we're going to multiply the power to the coefficient or the m over n. They're going to multiply to exclusion of the coefficient of n, if you were to solve
Ask again.
when we see the m over n,
Yeah.
are you going to times it? When you times it, it's going to be m over n, like m a over n to the power of 1 over n, or is it going to be times to the power also?
I don't follow.
Remember, you see what we're doing now?
Yeah.
Remember, is this going to be times to this?
No, I need to look at this. That is
No, I'm saying if we were to solve this, like these things.
Wait. Yeah, I understand.
It's going to be
Yeah. We'll do one like that. Let's say we have something like this. Cubed root of 4x to the power of 10. First you have to rewrite that as 4 to the power of 1 over 3 times x to the power of m over 3. Now we have to get the first derivative. Fx. So f accent x will be, this is my coefficient, that's my x, that's my exponent. The exponent must be multiplied with the coefficient. So m over 3 is multiplied with 4 to the power of a third times x to the power of m over 3 minus 1. Nice question for the exam.
Oh, it's minus 1, not minus 1.
No, minus 1. Okay. Now we have different notations for the same thing. Let's say I give you fx equals x to the power of 4 plus 6x minus 3. I can ask you, get me this. Okay, that one is easy. We've done a lot of examples like that. But I can also ask you, let's say this is a y. Y equals that. That's also a function. How do I ask the first derivative of that one? Are you awake? No, ma'am.
Yes.
Fast awake? Yes, ma'am. So the first derivative can be asked like this. Or take the y, oops, and differentiate x. So I can ask you this notation, or that notation, or that notation. If I ask you this notation, you will have 4x to the power of 3 plus 6. If I ask you that notation, you will have 4x to the power of 3 plus 6. This notation, the answer will be 4x to the power of 3 plus 6. But I can also ask you the same function like this. That's another type of notation. It means differentiate x in that function. Then your answer will be 4x to the power of 3 plus 6.
Did you work this out in your head?
Hmm?
Did you already work this out?
Yeah.
Oh.
Or I can ask you, that's another notation, another way of asking you to get the first derivative. That will also be, take the 4 to the front, 4x, make the 4 1 less, to the power of 3 plus 6. So different notations asking the same thing. Any questions? I have 3 more examples. Fx equals x to the power of 4 plus 6x plus 7. Now I have 3 terms, but you have to get the form correct for every term. So, there's an x, there is the exponent, and the coefficient is 1. There is x, the exponent is 1, coefficient is 6. There's my x, Exponent is what? 0. Coefficient 7. Now I can get the first derivative. 4 times 1 is 4. X to the power of 4 minus 1 is 3. Plus 1 times 6 is 6. X to the power of 1 minus 1 is 0. Plus 0 times 7 is 0. Okay? I can still simplify that. So it's 4x to the power of 3 plus 6.
And do you get a mark for making sure that the form is correct?
No. This is just to help you to make it correct. Our next example. Gx equals 4x to the power of 5 plus 5 pi plus t squared. I need to differentiate in terms of x. So I must make sure that all the x's have 3 boxes. There's a box, there's a box, there's a box. This one doesn't have an x, so you need to put an x in. X, box, coefficient. 0, that's a 0. X, 0, coefficient. 5 times 4 is 20. X to the power of 4. Plus 0 times 5 pi is 0. Plus 0 times 2t squared is 0. So my answer is only that. Any questions? Last one. Are you still with me?
Yes.
Barely. Y equals a third x to the power of negative 6 plus x plus x to the power of 3 over 3. I want take y, differentiate x. First get the form correct for all the terms. There's the x, there's a negative 6, there's a coefficient. There's the x, there's a 1, there's a 1. There's the x, there's the exponent, and here is the coefficient. And now you multiply. Minus 6 times a third is what? Minus 2. Wakey wakey. Minus 6 minus 1 is what? Minus 7. Are you awake now? 1 times 1 is 1. X to the power of 1 minus 1 is 0. You have to write the 0. Plus 3 times a third is 1. X to the power of 2. You can still simplify that, and you are not allowed to leave your answer with negative exponents. So we still have to simplify that as well. X to the power of negative 7 means that x to the power of 7 goes to the numerator. No, denominator. Minus 2 over x to the power of 7. Plus x to the power of 0 is 0. 1 plus x squared. And now you're done. Will you be able to do this? Yes, very easy.
However, he has to reverse that back to E.
Reverse? No, that's integration. You do that first year university.
When you study maths.
When you study maths.
Maths.
Pure maths. Alright, your homework for tomorrow is exercise 4, page 16, number 1 till 14. It should take you 15 minutes. If it takes you longer, you have a problem with multiplying and minusing.